तो आज हम NMOS फैब्रिकेशन प्रोसेस को देखेंगे। तो NMOS fabrication, there are large number and variety of basic fabrication steps used in the production of modern MOS ICs. The same process can be used for the design of NMOS or PMOS or CMOS devices. The gate material could be either metal or polysilicon. The most commonly used substrate is bulk silicon or silicon on sapphire. In order to avoid the presence of parasitic transistors, variations are brought in the techniques that are used to isolate the devices in the wafer. This is basic diagram of NMOS fabrication process. The fabrication steps are as step 1. Processing is carried on single crystal silicon of high purity on which required P impurities are introduced as crystal is grown. This is what it looks like in step 1. Next step, a layer of silicon dioxide, typically 1 micrometer thick, is grown all over the surface of the wafer to protect the surface, acts as a barrier to the dopant during processing, and provide a generally insulating substrate onto which other layers may be deposited and flattened. This is what it looks like after 1 micrometer thick layer is grown all over it. In step 3, the surface is now covered with the photoresist, which is deposited onto the wafer and spun to an even distribution of the required thickness. This is the photoresist which is deposited onto the wafer, and in next step, the photoresist layer is then exposed to ultraviolet light through masking, which defines those regions into which diffusion is to take place together with transistor channels. And in step 5, these areas are subsequently readily etched away together with the underlying silicon dioxide so that the wafer surface is exposed in the window defined by the mask. In step 6, the remaining photoresist is removed and a thin layer of Si2 is grown over the entire chip surface, and then polysilicon is deposited on the top of this to form the gate structure. The polysilicon layer consists of heavily doped polysilicon deposited by the chemical vapor deposition. This is the diagram for step 6. In step 7, further photoresistor coating and masking allows the polysilicon to be patterned, and then the thin oxide is removed to expose areas into which N-type impurities are to be diffused to form the source and drain. Note that the polysilicon with underlying thin oxide and the thick oxide acts as mask during diffusion. The process is self-aligned. After step 7, it looks like this. Thin oxide, the polysilicon coating and allows the poly to be patterned. And in step 8, thick oxide Si2 is grown all over again and is then masked with photoresist and etched to expose selected areas of the polysilicon gate and the drain and source areas where connections are to be made. And in step 9, the whole chip then has metal deposited over its surface to a thickness typically of 1 micrometer. This metal layer is then masked and etched to form the required interconnection pattern. So after step 9, the metal is contacted here like is masked and etched to form the required interconnection pattern. So this is the steps of NMOS fabrication.